For pretty much all of human history, we've had this natural tendency to put ourselves right at the center of everything. But science has been on this long, humbling journey of slowly but surely kicking us out of that special spot. So let's go on this little journey together, this great cosmic demotion, and uncover the mind-bending reason why the universe might not have a center at all.
It seems like such a simple question, doesn't it? I mean, you'd think there would be a specific spot, a cosmic "you are here" sign floating in space. But the answer physics gives us is so much weirder and honestly, a lot more profound than you might expect.
Okay, so to really get this, we've got to take a step back. This whole story is really a series of demotions, where our little spot in the universe kept getting smaller and smaller as our understanding of it got bigger and bigger. And you can see this crazy pattern, right? Each one of these steps was a huge hit to our cosmic ego. First, we thought we were the absolute center of everything. Then, nope, just a planet orbiting a star. Okay, fine, but that star is at the center of our galaxy, right? Nope, again. And then, finally, in the 20th century, we got the last big shock. There's no special center at all. The demotion was, well, complete.
So what's the actual science behind this wild no-center idea? It really boils down to something called the Cosmological Principle, which is kind of like the universe's fundamental rule for playing fair. No cheating, no special spots.
The first part of this rule is something called homogeneity. All this means is that if you could zoom out, way, way out, the universe would look pretty much the same everywhere. Yeah, up close it's lumpy. You've got planets, stars, whole galaxies, but on the biggest of scales, all that lumpiness just averages out. Kind of like crumbs in a well-mixed cake batter. No single part of the universe is fundamentally different from any other part.
And the second part is isotropy. This just means the universe looks the same no matter which direction you look from where you're standing. And the best evidence we have for this is just incredible. It's the cosmic microwave background, this faint afterglow of the Big Bang, and it is almost perfectly uncannily uniform across the entire sky.
And here's the kicker, where it all snaps together. If the universe looks the same in all directions for us, if it's isotropic, and we make the pretty safe bet that we're not special, then it must look isotropic for an observer in any other galaxy too. And a universe that looks the same from everywhere, well, it has to be the same everywhere. It must be homogeneous. No special views means no special spots, which means no center.
But hold on a second. You might be thinking, if everything's moving away from us, doesn't that make us the center? And yeah, that's the big paradox. The solution is one of the coolest, most mind-bending ideas in all of science. It's not that galaxies are flying through space away from us, it's that space itself is stretching.
Okay, let's just rip the Band-Aid off right now, because this is the #1 misconception out there. Forget any image you have of a single firecracker going off in a dark, empty room. The Big Bang wasn't an explosion that happened at one point in space. It was the beginning of space and time and everything, happening everywhere all at once.
This table lays it all out perfectly. A normal explosion has a clear center, a point of origin. But with metric expansion, the correct model, space itself is growing between things. Every point is moving away from every other point. So there's no single center. Or another way to think about it is that everywhere is the center. This is also why it's possible for some galaxies to be moving away from us faster than the speed of light. It's not the galaxy breaking the speed limit, it's the fabric of space between us stretching that fast.
All right, to help wrap our heads around this, let's pull out the classic balloon analogy. Now, it's not a perfect one-to-one, but it does a fantastic job of getting the main idea across. Just imagine our universe is only the two-dimensional surface of a balloon, and all the galaxies are just little dots we've drawn on it. Now, start blowing up the balloon. From the perspective of any single dot, what does it see? It sees all the other dots moving away from it. And the further away a dot is, the faster it seems to be moving away. Sound familiar? But here's the key. Is any single dot the center of that expansion on the surface? No, of course not. The true center is inside the balloon, which isn't part of their 2D universe. The same logic applies to our 3D universe. Okay, so we have this beautiful, elegant, tidy picture of a perfectly uniform, centerless universe. But science is never quite that simple, is it? Just recently, astronomers have started finding some weird anomalies, some cracks in this perfect picture that are starting to challenge this whole idea of perfect symmetry. So for starters, we're finding things out there that are just way too big. According to our models of how the universe should be smooth and uniform,
Things like the Hercules Corona Borealis Great Wall are so unbelievably massive, they just shouldn't have had enough time to form. These behemoths are a direct challenge to that core idea of homogeneity.
And then there's this thing with a name that sounds like it's straight out of a movie, the axis of evil. You just can't ignore a name like that, right? It's all about these strange, large-scale patterns in the cosmic microwave background that seem to line up suspiciously with our own solar system. And that shouldn't happen. It hints that maybe, just maybe, our spot in the universe is a little bit special after all.
And to top it all off, we've got this other puzzle called the dipole tension. The simple version is, it's a mismatch in our measurements of the universe's expansion. It's almost as if the universe is lopsided, expanding differently in different directions, creating this massive flow that our perfectly balanced model just can't explain. But don't worry, the cosmic detectives are on the case. The Euclid Space Telescope is, as we speak, building the biggest 3D map of the cosmos ever created, specifically to investigate these strange findings. We're right in the middle of a huge detective story, and the big clues are expected to start rolling in over the next couple of years. Okay, with all of that swirling around, all these cosmic mysteries, let's bring it back home. Back to you. How do we square that feeling we all have, that we are at the center, with the scientific fact that there isn't one?
This is really the last piece of the puzzle, isn't it? When you look up at the night sky, you see stars and galaxies in every direction, stretching out to some distant edge. It sure feels like you're in the middle of a giant sphere of stuff. So what's really going on?
The magic word here is observable. Look, the universe is about 13.8 billion years old, and light travels at a fixed, finite speed. That puts a hard limit on how far we can see. It creates an observational horizon. So you are, by definition, at the absolute center of your own personal bubble of the universe. But it's a center created by time, not by a special place in space.
And this is the real clincher. An alien astronomer and a galaxy billions of light years away, they are also at the center of their own observable universe. Everyone, everywhere in the cosmos, is having the exact same experience of being at the center. And that's what it means to live in a universe without a physical center. So, to really blow your mind one last time, let's ask the ultimate question. Where did the Big Bang happen? The answer is incredible. It happened right where you were sitting, and over there, and across the galaxy, everywhere. Since the Big Bang was the beginning of space itself, every single point in today's universe was there at that first moment. The center of the universe is, quite literally, all around you.
So in the end, this cosmic demotion, it wasn't really a demotion at all, was it? By losing our claim to the center, we actually gained this much deeper, more profound connection to everything. We're not some special point in an empty void. We're just an integral part of this incredible expanding whole, where every single point shares the same amazing origin story. It's a beautiful thought, isn't it?